Okay, I will use this updated demo app for particle swarm optimization to teach you how to create a new benchmark. The first thing is you need to find the solution and find the equation or your function and make sure it is not duplicated. All right. So, for example, if I came up with this new benchmark, for example, it's an egg hold function. So like an egg hold box, right? Formulation is right here, and also we have global optimas right here. This is a two-dimension, right? So x and y has their lower bound and upper bound. So if I intended to implement this one, the first thing is you need to check the bank library to see if it exists or not. So it starts from egg holder, and I think this is a new one, right? We do not have any benchmark name in the title or egg holder. So in this case, I would like to create a new COP file for this automation function. So I click on new benchmark. So the title, right? So maybe I can copy it. All right, let me move a little bit to the left. And here's especially the title. And I use a pair of parentheses to show the dimension. Since the dimension is 2, I can add it there. And it's a minimization problem. So okay. And how about the range? The range is minus 512. Okay, so x is a minus 512. Okay, so it's a minus 512. As you know, since they share the same bound, so it's okay. The system will automatically update this lower and upper bound for you. Dimension is 2, minimization. Is there any non-global optimization solution? Yes, we have. We have one, and the objective value is here, minus, oops, I cannot do it. So the only way I can do, just type it. It's not good at all. So objective value is minus 959.6407. Okay, and then x value 1. So x is 404.2319. Okay, so I kind of specify the global optima solution right here. So make sure everything is okay. All right, then so you need to put more information for your user. Okay, so basically that is a rich text file. So actually we can do the equation. So I pop up the word, try to type an equation, and then copy and paste it to the rich text box file. So let me supply the information about the title again. So it's an egg holder function. Title egg holder function, and it is from wiki, right? So my copy principal function for optimization source, and probably you can add a hyperlink, the URL to let the user to easier find it. So in that case, the user can check out this file. And how about the dimension? Okay, so we need to have an equation xy, right, and a minimize equation. So I intended to type this inline function. So minus 512 small equal x and y, right? This is the upper bound and lower bound 512. Okay, I got this equation. This is the range, right? And I add another equation. try to describe the objective function. So right here, let me a little bit check it. So minimize, right? Minimize what? Minus pairs of parentheses y plus 47. Then sine. I had better use oh well, it's okay. Square root, right? Then absolute value x over 2 x over 2 plus y plus 47. Okay, this is sine minus, oops, excuse me, minus x times sine. Again, it's a square root, absolute value x minus y minus 47. So we can take the minus sign, means tear up the parentheses. So this is the value we have. So minimize this function. So probably that we might have this notation specifically saying that the variable are x and y. So this is my objective function. So probably that's all. So we don't need to refer this information anymore. So right now we have our equation, right? Okay, we copy it, paste it, minimize f of xy, and this is the range of xy. Copy it, paste it to this place. All right, we do not have any grading information, so leave it blank there. Ultimate value, well, we know that, right? Ultimate value. Copy it. Ultimate value, well, it's minus 900. Then the ultimate solution, okay, I can write it again right here. So ultimate is xy equal 112, 404, 319. All right, this is our ultimate solution. So copy it, paste it to this place. And since it's a unique global ultimate, so we can put it right here. Alright, then it's your credit, so added by what? FC, put your name down here, and then make a date. It's December 24th, 2018 years. So it's okay, but you had better means probably add another figure here later on. Right? So the most important thing is that you need to write a C# programming language, try to return this value. So basically you are asked to do what? To compute this function, at least this function. This is get objective value, right? So you have been supplied with a program specified double array x. So which means that x should be x0, y should be x1, right? So you need to use this notation. This is by default have implemented in the code. And what you are about to report is the value of objective. So you need to type this variable correctly. Okay. So in order to complete this complicated formulation, actually you can add as many local variables as you like. So suppose right now I have double. I might call it y plus 47. That should be x1, right? Plus 47. Okay, and then I have double sine 1. So math sine math, square root, math, FBS, absolute value, right? So let's put x0 times 0.5 plus x1 plus 47, parentheses, for the absolute value function, square function, right? Sine function. Okay, that's it. Double sine 2. Well, I might call it x sine 2. So equal what? X zeros times math sine math square root math absolute value x0 minus x1 minus 47, right? Absolute value square root sine. Alright, so everything is ready right now. I can return the objective value. So I simply use this statement objectave equal what? Minus yp 47, right? Times what? Sine 1 minus what? X sine 2. Alright, it's pretty easy. I mean, you can create local variable to hold temporal value for you in order to compute the total value or the objective value. Alright, so once you finish it, you can click on this button, try to verify. So once you click this button, the application will invoke the C# compiler, try to compile your code in the real time, so to see if there is any error or not. So click on it. Your code is okay, then that means this is acceptable right now. If accidentally you type something wrong, so once you hit this validate, then the compiler will tell you what kind of problem you have. So as you can see, this code has a bug. The compilation error listed below. Well, objctave does not exist in these contents, so you know, and through this information, you can debug your code. I mean, let's say objctave exactly. So make a final check again. All right. I think everything is done. So this place you can just leave the blanket. So once you have gradient information, you might need to report gradients. So you will do a similar way. Because gradient is a vector, so you need to return G, like that. And probably you might, when your automation is about to create, you might have a global operation right here. So you can do it right here. It's okay. And basically, what you about to do is try the application try to correct the code that you type and associate with this pre-typed source code, compiled as a class. You see, this is a class automation problem, and you can do the initialization there. So you can put member function, define member function here in order to be used in objective function calculation or gradient calculation. So actually, it is not so typically you are actually write a source code or a class that the C# compiler compiled, and then we can access that. All right, so once everything is okay, you need to save the file name, right? So suppose I want to save to this place, so I will save as. All right, so navigate to this bank. All right, to here. And by default, it says I kind of use your title egg holder function to COP. Not just COP file is created, right? So we also have a RTF file ready. So save it. A new problem is created. So right now you have a new problem created. Then we close it. So we can open it once we create it, right? Now, okay, egg holder function is right here. So you can make it slightly, display. You can display your function right here within this function to see if it's look like the same as shown in your original file or not. So this is the one we have. So once you have this snapshot, right? Well, we can take a snapshot by hit the Control Alt print screen key. So right now I have this guy. So let us see what kind of image we have. We kind of dump the screen image of this application, and then I might just move a little bit to this place, so I can use a rectangle to click this region because this is the function, right? This is the function, so we copy it, kind of copy it. So we copy to where? Copy to the clipboard. So in this time I can, because right now we have already in this benchmark, right? So we can add it. So through the edit, you see the same information pop up right here. But this time I can add the figure to this RTF file. So if I paste it, I have nicely displayed figure of this function. Well, I think actually you can. Why I cannot resize it? I don't know. Maybe it's not resizable. But anyway, once I modify, I need to save again. So I simply save again. Okay, so it's almost done. Is for a new benchmark adding. Well, if I shift to another one. Okay, let me try another one. Okay, and then I go back to open the one I just created. You see, in this case, you will see rich text file to contain not just equation but also a shape function there. See, that is the point. All right, since we have opened it, so we can ask the PSO to find the Ultima for this newly created benchmark for us. We set. We know the global Ultima is right here, minus 959. The global solution is here, right? So it's far from the global Ultima, right? It's a PSO. If we take a look at this global Ultima, we don't know exactly where it is, right? 500 probably is around here. X1, X0. No, X1 global Ultima should be. This is Y112, so it's in the bound. It should be on the boundary, right? On the boundaries and Y. So probably the global Ultima might somewhere. Might exactly their place. Okay, yeah. We have global Ultima shown right there. So again, what you have right now is still far from the global Ultima, right? So it's a top problem. So if I try GA to see if we have better luck or not. So this is behavioral GA. It close, but still it does not hit the global Ultima. But probably might have a chance. We don't know. So it's much better than PSO, right? Well, in this case, usually we will have employ a large population for solution test, for solution search. So what we are running is GA, okay? Well, again, it is not global Ultima at all. So you see, this kind of benchmark, we have a bunch of this kind of benchmark to try to test your algorithm. Okay, so but in this point, or sometimes you might specify a large value iteration limit, right? And once you hit it, you click on the run to end, but nothing. The problem is you like to hit a button to stop it before it reach the iteration limit, right? But sometimes we like to terminate execution and try to run another benchmark. But right now, there is no any such kind of opportunities. So what I'm going to teach you is that we try to modify our code a little bit to let this capability available. All right, so I don't have any choice. The only way I want to stop it, just terminate it. But so far, the global solution is closed, right? It's closed a little bit, but still it is not global solution yet. All right, so let me just terminate it. All right, so this is another topic I'd like to share with you. So I will teach you how to do the so-called multi-threading programming. So let's go back to the our source code. So right now, if a user click on the run to the end, we like to change the face text, change it into the stop or pause anyway, pause or stop. It's okay. And then once user, by the time user can click on the stop button, and then our code since this flag has been turned on, so the execution will be terminated somehow. But let's take a look about the current implementation. Since we have since we have PSO and GA, so we have both cases, and there is a file loop there, right? So there's file loop there. So we intended to multiply it a little bit. So we try to change it first. So in that case, am I saying that if btn run to end, the face text is exactly equal run to end, run to end. Then else. Okay, and so this is once run to end, then we change face text. So btn run to end text equal stop or pause anyway. But actually, the meaning is actually like a pause anyway. Okay, otherwise the text will return run to end. So let me temporarily, make this part as comment. Make this part appear as comment. So let's see what kind of user interface we would like to have. So once user ready in a benchmark, click on solver, reset, run to end. Wow, it does not work. Okay, let me see what's wrong. If it's run to end, oh, okay. Capitalize 2. Capitalize 2. Okay, I'm sorry about this. Capitalize 2. Ring a benchmark, created, reset, run to end. So it changes to so behind these buttons, the for loop is running, right? The file loop is running. So once user click on stop, and then the execution should stop, and then let the user regain this control. That's what we want. So we need a flag. Somehow we need a flag. Suppose right now we have flag. We call it bool. Stop it. False. So initially it's false. So when the button face turn out to be stop, right? So in that case, we will turn this stop to true, this flag to true. Okay, we need to turn it to true. And then after everything has gone back, then we should start from here. Stop. Resume the stop it equal false. Okay, that's the whole idea. But right now, since we are about to write the so-called multi-thread application, we will create a new thread for the either PSO or ACO to run it. So that is the whole idea. So basically, the thread execution, the test code for the thread is to carry out this while loop, right? So based on different kind of solver, we will invoke a different kind of thread. So in this case, I might need to have thread, T-H-R-E-A-D. So a new class, I mean, you guys did not use it before. So we need to include the namespace. It is specified within this system.threading namespace. So I'm going to call it PSO thread. Another one is a GA thread. Okay. So we have thread, right? So stop at equal false, and then so we will create a thread if RDB radio button PSO quick, if RDB PSO check it, if it is PSO threading, right? So then we will new this PSO thread. Otherwise, we will new a GA thread. So since it's a PSO, so PSO thread. Probably I might just need one thread. Let me think about that. Okay, I might better just use the word thread. That will be much simpler. So I changed my mind. I kind of change into rename it into run thread, run thread thread. So no matter whether it is PS or GA, I use the same thread. So run thread, I need to new it, new thread. And in order to carry out a thread, you need to have instance called thread start, new thread start. Thread start is actually a delegate. It represents a function that takes no argument and return nothing, return void. So in this case, I can new thread start. Thread start is a delegate, right? So I need to have a function prepared. You see, let's take a look at this here. We need to prepare a function. This function take no any argument, return void. So that function will be called. So and then by that time, so we need to specify a function. I will call it this function is run to end function. Okay, I did not have this function yet. It's okay. So the query line came out, but I asked the you see, I did the Visual Studio create that function for us, run to end function. So run to end function look like this one. So basically, this thread start actually is a delegate. This delegate is the event handling function is that take no any argument, return void. So run to end function is put here. So right now I have thread. I can start it. Run thread start. Okay, so the whole idea is that multi-threading function right now, we create a thread. We create a new thread. Let the thread run the evolution algorithm right here, PSO or GA right here. So within this function, okay, let me see. It can access. I don't know whether it will work or not. Probably it does not work at all because user interface. I don't know. Let me try it. Otherwise, we need to change it a little bit. Let me check if I can access RDB PSO. Check it. The problem is that radio buttons and all other user interface control are management by the so-called main thread. But right now, we ask this thread, we create a new thread, right? This thread will run this function, and this function is not supposed to deal with any UI control. Otherwise, the computer will complain. This is where this work or not. I don't know. Else. All right. So up to this point, what I have changed is that once the user click run to end, then I change the phase and create a new thread. So let me set a breakpoint here to let you know what happened. No, since it's stop it. I kind of activate release bar mode, so I need to change it back to debugging. Ready? Okay. Where's my bank? New should be bank. Egg holder. Okay, I got it now. So PSO create solver, reset, run to end. So we are about to create a thread, new thread. So thread is created. Right now we activate this, we execute this thread. So continue. Well, also it's good. Okay, I did not do any changes, so it worked. Okay, it worked. All right, so let us prepare our code right here. See, we have our run code, the run to end code, right? So basically, what you need is just copy these parts. It's the PSO, right? PSO button. Otherwise, we run this one. PSO. See, if it is PSO, we ask the PSO because the PSO is instantiated, right? Has been said. So it's good. But right now, why we need to check the condition, right? If file none, stop it, and solver condition not met, we'll continue with this step, right? So this is the whole point. We add another, we add a flag for start for terminate the execution, right? So we need to put a condition right here. So not stop it. So let us see what happened. Create solver, reset, run to end. So I remove this breakpoint. All right, error come out, right? Remember what kind of function we have? We invoke this function, right? Button run one iteration quick. So this function, as you can see, run up to this point. Button run one iteration up to this point. RDB PSO check is okay. Run one iteration is okay, but error came out. No, you need to pay attention to that. Right now, this function is executed by what? By the thread. The thread is not the main thread. The main thread of the application. So only the main application, only the main thread of the application can access the UI control. But right now, this thread execute this function, and it try to update user interface stuff. Right? See, line average error, the XYZ pointer. So these are not allowable. As you can see, if you it's a multi-thread, this kind of operation is embedded. The UI control, the UI control is created by the main thread, right? So only the main thread can manipulate or change the attribute of that UI control. But right now, the thread running this function is created by us, right? So it's a new thread. This thread did not create this UI control. So this thread cannot access the properties or cannot modify or access property of this control UI control. So we can. So in this case, we need to prepare another function. We need to ask what? We need to ask the main thread to deal with this kind of user interface changes. All right. So in this case, we need to move this function out. So this function, suppose I prepare a function, try to do. So I'm gonna call it update UI main main thread. Update UI by main thread. So I copy these 2 or 3 lines there. No. Copy, simply copy. Label 2, right? Resolution RTB, which text box clear, right? All this stuff. Control C, paste it. So it's about the time I kind of make them, no, not this one, make this UI related statement, make them appear as common. So basically I kind of remove this function and refresh too. I mean these parts too. So I needed to copy them again to this function. So make them comment. Oh, okay, there's a progress bar too. So everything just copy to this function. So this function is related to UI control, right? So it should not be done by the extra thread that we created for running the automation evolution. So comment it out. So similarly, within this function, I needed to comment it out. So it turned out to be very simple. I mean, for this button click, loop through, right? Loop through the run one iteration, PSO over GS over. But right now we need to update this. We need to update user interface, right? So how can you invoke this function? This function should not invoke by this thread. This function should be invoked by the main thread. So what we're going to do is that we will ask this. This means that the object of this form invoke some function. But this invoke function needed to have a delegate represent that function, right? So we will do a little bit different. So means for either way, for PS solver, for GS solver, they share the same logic, right? So we don't need to put in right here. So we probably is after execute one iteration, then we will ask form. We will invoke. We will force the main thread or this form to invoke the function. Invoke which function? Invoke this function. Update UI by main thread. Update this function. But since the invoke cannot invoke the function directly, you need to use a delegate to represent this function. So it is a little bit troublesome, but simply follow me. So right now we have form, right? We have class already there. So within this form, I can define a delegate. So I call it delegate, and this function does not return anything. I will call it update delegate. Update delegate, and then take ignore any argument. So within this class, I define a nested delegate. The name is update delegate. Since I have this class already, right? So I can say update delegate my update function. Alright, so I kind of specify a new type. It's a delegate type, and then I have a variable in this data type. So by that time, my update function can be assigned right in the constructor. So my update function assigned with what? We just take in the update. Can I remember the function name we just create? Let me check it. The function we put everything there, right? Update UI by main thread. So update main UI, update UI by main thread. So it's kind of indirectly function invocation. You need it. You are not going to directly call this function. You kind of ask the main thread. Ask the main thread invoke a function. But since you will use invoke, you need to special a delegate, not a function. So right now my delegate is right. my update function. Okay, maybe I change it a little bit. I might change this function to rename it. My update function delegate, delegate. It will be much clearer. So right now in my system, I have my update function delegate, and also I have update function, right? We have update function special update UI function, right? So in that case, I can assign this function to the delegate. So and then the main thread can invoke this function via this delegate. So invoke my update function delegate. So it's kind of amazing. It's kind of very troublesome, but this is the only way you can do it. All right, so let me clean up the code. So kind of clean up the code right here. All right, clean up the code right here. But we need to do a little bit modification. See, so now the button click is very simple. You PSO, check it. PSO run one iteration. GA server, GA run one iteration. Invoke this update function. Let us take a look at this update function. As you can see, you see PS server, right? This function is for the PSO, right? It's for the PS server, not for the GA server, right? So how can you do that? How can you change that? Well, there's no way we can just use the check-in if RDB PSO check it and do these parts. All these parts are related to the PSO. Else, that means that is for GA, right? So the easiest way, not the best way, okay? I simply copy everything, paste the heat to these parts, and then modify the code. I will use GA server to replace all this stuff, right? So either way, I can use oil highlight PS server and change it to GA server. Double click it, then change it, then change it. Or otherwise, I can highlight this portion, right? And check the edit command, quickly replace. So PSO server, change into GA server. Hit this button, replace all. Oh, excuse me, made a mistake. Okay, PSO server. Hit return. So 10 PSO server has been replaced for you, right? So let's check it with GA server, right? GA server. Some of the best solution. I think that's it. All right, so we can start. All right, so error, just debug it. Real number GA. Individual best solution. Oh, okay. It's a little different, right? For PSO, they have an individual best solution. So the parts will be a little bit different, I mean, from PSO. So we need to change it for the GA. So GA, well, GA server, right? RTB abandoned solution, display solution, GA server solution, individual best. No, we do not have this kind of information, so we just leave it out. Because that is for the PSO server, right? So we do not have it. For GA, we just have so far the best solution only. Okay, I think that will be all. Solution 1, display solution, GA server. All right. So suppose open egg holder. And then PSO, create GSO, reset, run to end. Okay, so normally it's okay. How about GA? So let's check everything is resume, reset, run to end. It's for GA. It completed, right? It completed, but you see, the face, bottom face does not look right, right? Think about that. Once you give this information to a new thread, once thread run to the end, thread does not know anything about this button at all. So naturally, your logic is still not complete yet, right? So later on we will do it. So let us reset it, and then stop it, restart it, stop it. So right now stop is working, right? Because we kind of once you click on stop button, the flag has been turned on, so the while loop will be terminated by your code. So in that case, this button work, but the logic does not seem quite right, right? So if the thread automatically finished, then we needed to do something to do something. So in that case, we might need to have what we'll see. Once we hit the button, once we hit the run to end button, create a new thread start, right? And thread is right here, run to end function. Run to end function here. Run to end. This is the thread. So thread just keep a loop through each iteration by iteration. At the end, it's completely. It simply end up right here, right at this point. So remember that this function is executed by another thread. And if you want to deal with any UI interface, you need to have another function. So probably in this case, we will need the help again from the main thread or the UI. So we call this invoke another function. So another delegate, right? So we need to prepare another function right here. Okay, so we have my update function delegate, right? Well, okay, we have update delegate. All right. Well, I have better use a different kind of variable. So again, update delegate. My update function, my end o thread delegate. End of thread delegate. Okay, so we have another one. How about the function? You have run to end. You have update. Let me check. Display run to end, right? Okay. The run to end function right here, right? We have update. Here. We have update my main thread, right? So we have we will create another function void update UI resume UI by main thread. What kind of thing we need to do? If the thread is successfully complete, we needed to change what? We needed to set the R button btn run to end. We need to change the face, right? Change the text into run to end. So we need to do this post process. And also we have better than stop it equal false. Somehow maybe we don't need it, but we still need this function. So this function will be represented by this delegate, right? So we have my UI function, my end of thread delegate equal resume i.e. SUME, resume UI by main thread. Okay, so we kind of set up two variables of this delegate, and then we will ask. So once the thread successfully complete, right, up to this point, this thread will ask the final task will ask the main thread to invoke that function. That should be my end of thread delegate. Okay, so that's it. So suppose I open a benchmark, then click on GA, reset, run, stop it. So once I stop it, right? Stop it, resume to 2020. So I can reset everything, right? I can run again, stop it. Run, reset, run again, stop it. Oh, okay, we cannot reset it. Alright, so you need to, well, let me do it again. Create, reset, run to end. So usually, once run to end is hit, we are not going to let the user click on reset and run one iteration. So that is the so-called for proof, right? So you see, once thread is successfully complete, this button has been resumed. So the whole idea is that if you, in order to terminate your loopless, I mean your endless loop, I mean somehow you need to put a flag there, and if you let the user click on user interface to signal this flag, then definitely you need to use multi-thread programming. So that one thread run your code iteration by iteration, but the main thread still remain here, try to get the user's input. But in that case, it will be dangerous. I mean, user might click on reset, might click on run one iteration. So what shall we do? We will disable these two buttons once user click on run to end. All right. So we will make this logic much more complete. So once user hit the run to end, then btn run one step, run one iteration, enable equal btn reset, enable equal false, right? And after that, I mean, if it is stop it, right? If it stop it, so user might need to resume. So we need to resume it right here, turn it to be true. And also, once the thread is successfully complete, the update with our update. Resume UI by main thread. We also need to resume the inabilities of these two functions. So it make it much more complete. So when we click on benchmark, create solver, reset it. Once user click on run to end, these two buttons will no longer be enabled. If user stop it, these two buttons can be reset to run again. Stop it, reset, run to end. If the thread is successfully complete, the button face change back to the original run to end, resume this inability. So make the UI logic complete. Okay, that will be all for today's extra instruction about the creating a new COP benchmark and do the multi-threading programming for providing such kind of interrupts or termination capabilities. That's it. That's all.